Okay, welcome back, student. Today we are going to discuss a new topic. The topic is how to find electric potential at any point due to an electric dipole. Okay, so our topic is electrostatic potential at any point due to an electric dipole. So this is our discussion for today. So let us see how to derive electric potential at any point due to an electric dipole. Okay, so for this let us consider an electric dipole which is of minus q charge here at position A and the plus q charge here at position B. This becomes a system of an electric dipole. Now these are separated by a distance 2a, so I will write this a here and I will write this a here. So a is the distance between the 2a is the distance between the two charges, that means the length of the dipole. So this is your position O. Now let us consider any point P. Let us consider any point P which is at a distance r from the center of the dipole, which is at a distance r from the center of the dipole, and let P be the dipole moment from minus charge to plus charge. So let theta be the angle made by the line joining the point O, the center of the dipole, and the point P along with the dipole moment. Okay, moment. So that is why this is angle theta. Now let us find out what is the total potential at this point P. So to find the total potential, there are two charges. One is minus q charge, one is plus q charge. So this point P will have the potential due to this charge, and this point P at the same time will have the potential due to the plus q charge at B. So here the total potential will be BA plus BB. So the total potential at P will be BA plus BB. Okay, so that is why we have to derive relation of the total potential at P, that is called B. So let us consider an electric dipole of length 2a and dipole moment P equals to 2a, q into 2a. So let us consider a dipole moment of P magnitude, okay, q into 2a. So now let P be any point at a distance r. Let P be any point at a distance r from the center of the dipole. Now this is what we have to introduce, that P be any point which is at a distance r from the center of the dipole. Now, okay, then electric potential at P due to minus q charge at A. Electric potential at P due to minus q charge at A, I will term this as VA is equal to K, the constant, Q minus q charge divided by A P, the distance. So the formula for potential is KQ by R. So here the distance is AP from here to here. AP from here to here. Okay, so minus q charge where K equals to 1 by 4 pi epsilon naught. Okay, so this further implies VA equals to minus KQ by AP. So this is your AP. I will term this is R1. The distance from कहाँ से कहाँ तक? A to P. So this is equation number 1. Again, potential at P due to plus Q charge at B, plus Q charge at B is VB is equal to K constant plus Q charge divided by BP, or this further implies BB equals to BB, potential at B is K Q by BP. Equation number 2. Now look here. So here one thing is that the magnitude of the magnitude, because potential is a scalar quantity, so that is why it is directly VA, potential at A, which is minus charge के लिए minus negative potential, or plus charge के लिए positive potential. Okay, so that is why for negative charge negative potential, for positive charge positive potential. Therefore, then what is the net potential at P? That is B equals to VA plus BB. Okay, or this further implies V equals to VA how much? Minus K Q by A P plus K Q by B P. Look at this. This is total potential. So we finally got the value of V as K common, Q common, 1 by BP, which is plus, minus 1 by AP, which is minus. So AP is distance from here to here, BP is the distance from here to here. So I can take this as R2 also. If I take R2 representing BP and R1 representing by for AP, then we can also write this equation as the net potential V equals to KQ, okay, all into 1 by R2 minus 1 by R1. So this is again another relation, which is equation number 3. So this is a required expression of electrostatic potential at a point, at any point, due to a dipole. Okay, now after this, let us have some modification here for about R1 and R2. Okay, for R1 and R2, let us consider that this some modification here on the figure. Okay, so if suppose this is distance from here to here, so I will plot the construction here. So I will plot a perpendicular line here, extending this O to M, and this is perpendicular, so this angle is theta, which makes this side as A cos theta. Similarly, I will draw a perpendicular line here, which is point as N. I will mark this as N, and the distance from O to N will be A cos theta again. Look here, the distance from A to N is A cos theta, O to M is also A cos theta. Why? Because this is A and this is theta. So it is A cos theta. Similarly, this is A and this is theta. So it is again O A cos theta. Okay, now look at this. So in practice, what do we observe? In observe is that if the point P is little bit far, okay, if the point P is far, but what we have is AP is approximately equals to PM, which is again equals to, what is a PM equals to? This is PO plus O M, and which is equals to R plus A cos theta. Okay, and BP is approximately equals to BP approximately equals to PN, which is PO minus ON, PO minus ON subtraction, so it is R minus A cos of theta. So if I substitute the value of AP and BP in equation number 3, so putting this value in equation 3, we get equation number 3 में डाल दिया, तो what do we get? V is equal to K constant, Q constant here, so 1 by R2, which is equals to 1 by R2, which is equals to BP R2, or equals to R2, which is equals to R1. Okay, so putting this value of this value in equation number 3, we get R2 is R minus A cos of theta for R2 minus हो गया 1 by R plus A cos of theta. Okay, now so this for implies V is equal to K, Q रहेंगे, then taking the LCM we get R square minus A square cos square theta, and now R plus A cos theta for this, and minus R, this will become minus plus, when you open the bracket, R plus A cos of theta. Now these two can be cancelled, then finally what do we get? Finally we get the value of V as K Q 2A cos theta, A cos theta, A cos theta, to A cos theta, to R square minus A square cos square theta. So this is again one more equation for finding the value of electrostatic potential at any point on the at a distance r from the center. Okay, now this is an assumption only guess when these particular certain condition that this AP is approximately equal to PM, then we can write in terms of theta. Why? Because this point is going to change. If I place the point here, then the value of theta is going to change. So the electrostatic potential is also a factor of theta. So that is why if you place here, the value of theta is going to change. So I can incline at any angle instead of this R1 and R2. R1 and R2 position will change according to this theta. So I am making the potential as a function of theta here. Okay. So now, okay, then case number one. Case number one, if say case number one, if P lies on the axial line, if the point P lies on the axial line, this P lies on the axial line of the dipole, that is theta will be equal to 0 degree. That is theta equals to 0 degree, that is axial line. Then V is equal to K Q 1 by 4 pi epsilon, the value of K Q 2A. Now Q into 2A हो गया, cos theta means cos of 0 degree divided by R square plus A square cos square 0 degree. So what do we get? We get K Q into 2A. What do we have taken? Q into 2A is dipole moment P, and cos 0 is 1. So R square plus या minus A square. So this is the formula for what? Electric potential at any point on the axial line of the dipole. Okay. और again इसमें एक और सब नोट है. If again R is very less than, very greater than A. That means for an ideal dipole or a very short dipole, if R is very greater than A, then we get it is equal to K P by R square only, where A is being neglected. A is being neglected. So we can have a formula for axial line here for any condition of axial line, and this is the for an ideal dipole, okay, on the axial line, okay. Now case number two में if P lies on the equatorial line, if P lies on the equatorial line, that means along the line theta equals to, on equatorial line theta equals to 90 degree. So if I use the theta equals to 90 degree, then V is equal to KQ 2A cos theta cos 90 degree is 0 divided by whatever it may be, 90 degree 0. So R square minus A square 0. So I will get, so this is V equals to 0. That means whatever point is taken on the equatorial line of a dipole, the potential. So if I take a dipole here, minus Q plus Q, the electric potential at all point on the equatorial line will be V equals to 0, 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 V equals to 0. So at all this point on the equatorial line, the potential will be 0. Okay, this is what we have observed about the electric also potential at any point due to a dipole. Okay, so remember this, okay. Take a note of this, okay.